All right, hello and welcome everybody to another episode of our Puget Systems live Q&A show. I've chosen recently to drop the podcast part of the title, so because I can do that. So big news. Everybody's coming off the high of yesterday. Everybody can talk about the new Intel 12th Gen Alder Lake CPUs, and as I remembered earlier today, we are also going to be talking about Windows 10 versus Windows 11, DDR4, DDR5. But the big topic, of course, is going to be the Intel CPU stuff. So yeah, this is going to be a big one, I think, because I don't know about you guys, but I was surprised to see the significant jump forward that Intel made with this new architecture, new CPUs. Yeah, this kind of was a surprise. I know everybody was kind of holding their breath, waiting. Are they going to do something big? Is this going to make a difference? And I don't know. So I guess we'll just start off. Matt, how did it work out for you? Like, were you shocked?
In some cases, yeah. There are some isolated spots where like it was just like insanely better, especially
Yeah.
like lower end stuff. What I think is funny is like, I've been keeping up on all like the subreddit, Reddit hardware, threads and stuff, and it's funny how many people were actually disappointed. It seems like, and I think a lot of that is because they're just looking at gaming benchmarks, and gaming benchmarks are mostly single threaded, and like that's the lowest gains with Alder Lake was the single threaded stuff because that's just like normal gen over gen performance. It's the multi-threaded stuff where the new hybrid architecture with performance cores and efficient cores, that's where it gets really interesting and cool. And just so many reviews out there aren't focused on areas where that matters, and we do. So that's why like we're way more excited than maybe Linus or many of those other reviewers.
Sure. So, actually, you kind of hit on a good point, and I'll turn it over to William because I feel maybe you've got more of your fingers into this stuff. So, the big little thing, performance versus efficiency cores. You want a little deep diver into what's different about these CPUs than last gen?
So it's something that CPU manufacturers have been doing on mobile for a long time now, on like phones and stuff.
Okay.
But
Yeah,
this is the first time, as far as I'm aware, that it's come to desktop class or even laptop class processors, I think. So the idea is, your operating system is going to be doing all sorts of little things in the background when you're doing other tasks. Most of us multitask and have things, Chrome might need a little bit of time in the background, even if you're not actively using it. But then you've also got high performance stuff. And instead of having just a bunch of cores that are trying to do everything, the idea was to split and have high performance cores that can be doing your active tasks, things that are, important where performance matters. And then instead of having a smaller number of total cores, dedicate more space to having a higher count of low performance cores that can handle background tasks and whatnot.
Okay.
So that's kind of what they've done here. And in the exact number of cores that are high performance versus what they call efficient cores depends on the SKU. So I think at the top end, it's 8 and 8. And then it goes to 8 and 6 or something, or 4.
And 4.
Yeah, and then it goes down to 6 and 4. I don't remember the exact breakdown, but depending on the SKU of processor, it's got a different amount of them. But what that ends up giving you is more overall performance. So if you've got something that can use both the performance and the efficiency cores, you're going to have better multi-threaded performance than you would have back with just 8 cores. That would be the equivalent of just 8 performance cores in the last generation.
Okay.
Now you've got 8 more cores that aren't as fast, but that's still something. And in multitasking situations, you've got those 8 that can handle background things, while the 8 higher performance cores just work on your main stuff. And I'm sure there's some subtleties to how Windows is actually breaking that down and threading things, but that's the general idea behind it anyway. And yeah, it seems to have worked out. I mean, we've seen some pretty solid performance improvements. Plus, then again, like Matt mentioned, there's also just generational gains in the performance of the individual cores as well. So
nice.
Yeah, but I don't. It's not just background tasks though, because like those efficient cores, like they are not slow cores.
Yeah, they're slower, but they're in the
slower,
like 3 gigahertz. I don't remember that. We've got it all the specs on our landing page, but yeah, they're certainly slower, but they're not we're not talking like 1 gigahertz sort
Sure,
of
sure.
slow or anything.
More like
Yeah.
4.2 on the performance ones, and then like 3.5 or so on the efficiency ones, that kind of a thing.
Something like that. And they turbo just like normal cores, depending on
that's
what
cool.
you're doing.
Okay.
Yeah. In fact, Houston, do you mind
what do you
switching
got
my
there?
screen real quick?
Sure.
So this is from the architecture day from Intel a while back, maybe a month ago.
Yeah. Right.
But you can kind of see, so like these dark blue are essentially is it chiplets for the normal? So there's 1, 2, 3, 4, 5, 6, 7, 8 of those cores, but in each one of those cores, for each one of those, you could fit 4 efficient cores. So that's why like they made the decision like, oh, do we want 8 cores or do we want 12 cores? So 8 cores plus 8 efficient cores or 12 cores total. And they made the call of this whole, not big little performance efficient, because each of these little cores is like maybe 50% the performance, but you can fit twice as many of them. So it adds up to a lot more performance overall on highly threaded tasks. But like lightly threaded tasks, like how many lightly threaded tasks are you going to be doing at the same time? Like you're not going to be doing more than 6 or 8. So like,
Sure.
yeah, who cares? You don't need more performance cores. Go ahead and
this is kind of
so
clever.
you can pack in more efficient.
Yeah. Oh, that's pretty neat. How, I wonder, is this going to cause, because I know Windows has an issue when they start getting into real high core count stuff. Is this going to play into that at all?
Probably. Like we're not at that point right now. So what is the problem is once you get above, yeah, it's 64 threads or 32 cores basically. That's when Windows has to break it up into multiple processor groups, and then you get into the same issues you get with like dual Xeon, where like this has to access data that's over there, so it's got to go across and then come back, and it just adds a whole lot of stuff. So unless the application is very well threaded, it's not worth it. But the problem is there's a lot of applications out there that aren't, I forget what it's called. It's like processor group aware or something like that.
Okay.
So like some of the Adobe apps are like that. So like Premiere Pro, it'll be like, oh, here's all these cores. I'll try to use all of them. And it actually makes performance way worse. That's why we rarely will use like 64 core Threadripper with Premiere Pro, or even worse, like the 38 core Xeon W is just like absolutely terrible because it doesn't know what to do and it just screws everything up. So yeah, once we get above the 64 thread point, it's going to become problems again, and it's applications are going to have to get better at not trying to use all of these cores that are cross groups. As long as they can figure that out, this will be good.
Okay.
Yeah, and that's interesting. You mentioned threads. That's one of the things that's also different. The efficient cores don't have hyperthreading.
Okay.
And they don't have some of the more advanced AVX features and things like that, which is why they can cram 4 of them in the space of one full performance core.
Yeah, that's why you'll see weird numbers like 16 core, 24 threads.
Like, sure, because only 8 of them.
Yeah.
Yeah. Okay.
So numbers look a little weird at first, but you figure it out.
Yeah. So I'll since we're kind of on the topic, I'll take this question from Charles Snippy on YouTube. He says, I remember something about the efficiency cores not working properly on Windows 10 due to the scheduler. I guess it's a Windows 11 thing where it's aware of the efficiency cores.
I don't think it's that they don't work. I think I don't know the exact details, but my understanding vaguely is that Windows 10 isn't as aware of the fact that there's a difference. Because like I said, this is the first time this has happened, right? When Windows 10 was being developed years ago, there was no need to implement awareness that one core is going to be different or better than another. And Intel would do weird things. They'd have like driver stuff where, they knew one core was going to be a little faster in some of these, the Mac Turbo Boost stuff. And so they'd put extra software in there to help Windows be aware that one of these cores is the one you should put the highest priority thing on. But yeah, with this change to having these different performing cores at the hardware level, that's what Windows 11 is supposed to be better at interpreting and figuring out how to prioritize what tasks are going on what. Because ideally, like we've talked about, you want the stuff where you care about performance on the performance cores, and then the background tasks or just extra threads. Like if you're doing something that is heavily threaded, like rendering, those are okay on the efficiency cores. You kind of want to just load up everything at that point. So Windows 11 is supposed to be better about that. Our testing, though, didn't necessarily seem to reflect a huge difference. I mean, some things are going to have no difference, like rendering. Yeah, we'll get to that in a sec. Rendering is not going to have a difference anyway because it just is loading all the cores either way.
Sure.
But stuff that is like lightly threaded or single threaded should, in theory, have some difference. But what did you see, Matt?
Yeah, it was really just one. We saw Photoshop was the only one where we saw a performance gain with Windows 11. It was a lot. It was like 25%.
What?
But that was it. But Photoshop is also the like most lightly threaded application we test. So it's the one that's most likely to have problems if like instead of going to performance core, it goes over to efficient core for a while. That's going to be a bigger problem in Photoshop than anything else. So
Sure.
that was why it makes sense. But I haven't even seen reviewers. Like I tried to catch up on some of the in Antec and Tom Hardware and all those guys, and from everything I saw, like it didn't make a big difference. My guess is that it'll make a big difference for multitasking, which isn't something you can test easily. Like all the testing everyone's done is okay. We're going to test this game or this application, and that's it, because that's how you do performance testing. But my bet is once you get into I'm rendering a video in the background and I've got YouTube playing and, I'm working in Photoshop and Lightroom's open to the side. That's where it might get more confused. And that's where Windows 11, I think, is supposed to have just more things that it's aware of.
Okay.
So hopefully then it'll be able to know that like, hey, you have Photoshop open and you are doing stuff. Yes, let's make sure that goes to a performance core. So that's, I bet, where it's going to mostly come into play.
I see. And it's going to be, that'll be interesting to see how, I guess how it decides, because what if you've got Premiere and After Effects? Both of those seem like they would be wanting performance cores, but like, is it going to be which one you have focus on? Is it going to be the one that's actually like, is it like a request sort of thing? Like the software is going to be like, hey, I need more help over here. It'll be interesting to see. Because I mean, I think there's already been like 2 major updates kind of things since these chips came out. It's only been a couple days and we're already seeing updates and changes to software to kind of handle it all. It's very, very crazy stuff.
Yeah, because there's a lot of different levels to it. Like I know there's like what is in focus is, I know, part of it. But there's also the individual applications can be made thread aware, and so they can like say like, hey, this has to be on a performance core, or like this could be on an efficient core. Because like even in like Photoshop or After Effects or whatever, there's lots of stuff that doesn't have to be on a performance core.
Sure.
Like sure, it can go on an efficient core. It's just like garbage cleanup and junk.
It just popped in my head too about with multi-frame rendering. Is this going to make a difference? I mean, because that's all about we can take advantage of all these cores and stuff. Is that only going to focus on performance, or does it do well with efficiency cores too?
I don't know. Either way, it does really well. So however it's doing it, we didn't see a difference in Windows 10 or Windows 11 with After Effects. So it's
okay.
Probably being good and aware. But again, like if you're only doing one thing that's really loading the system, that should be like the easiest case for a director. Like, hey, these threads are high load. Let's put them on the performance core. It's going to be those multitasking, which you're not going to find many reviewers doing that because it's so hard to test multitasking.
Yeah. I think this is a good question from Chris Meadmore on YouTube. I think this is going to cover a lot of people's minds. As an After Effects power user looking to update my hardware, is now the right time to jump into the new architecture, or should I stick with a Ryzen build?
I think that's got 2 parts. There's the performance side, which I don't know if you want to get into performance yet. We can't jump into performance, but there's also the platform is new. It just came out. Like we haven't finished our qualification, so we're not selling it yet because it's not ready. There's always bugs at launch. There's always things to get through. Motherboard options are super slim. Well, I'm sure William can talk more about that. So like, if you need to buy a system today, I think it's a lot more of a complicated question. If you can wait a couple of weeks until like everything settles and like all the initial launch bugs and supply issues get worked out, man, Ryzen you're going to have a hard time justifying using AMD on a lot of things right now.
Rough.
Yeah, and I would also say that like look at DDR5 results too, or wait for more DDR5 results, because that could make a big difference. And if you buy a DDR4 12th gen board right now, like you can't upgrade later. You have to get a whole new motherboard. So check that out. And if you're currently on like a 5th gen Ryzen or even 3rd gen, a lot of investment to get a little bit of performance improvement.
Yeah.
Yeah, William, how's like DDR5 and stuff looking? Is that
So DDR5 supply, at least for us, and I can't speak for everybody out there in the industry, but from our suppliers, it's almost unavailable. We were able to get samples in, but only a week or two ago, it was like last minute for our testing, and those samples were, excuse me, those samples were from companies that we don't normally use for this memory in our systems. So like our mainline suppliers haven't been able to get us any. And it's so like, because you were mentioning, Kelly, the boards are different for DDR4 and DDR5. The slots are not compatible. So we've also got the issue of the motherboards that have the specs and features we want for when we carry DDR5 aren't available yet anyway. So even if we could get the memory, the boards that we would want aren't available yet. So for the moment anyway, what we're doing is qualifying DDR4 boards. And Josh, our product qualification guy, is in the middle of working on that right now. So hopefully in the next week or two, we'll have some qualified boards that we can start moving ahead on. I know supply of the CPUs is really good. We've already got those on the shelf. And I believe the new adapter plates for the CPU coolers are either already here or available and coming soon, one of the two. So really, it's mostly just qualification of boards we're waiting on for the initial phase, and then DDR5 and DDR5 compatible motherboards for sort of the second phase. So kind of a weird launch here with it supporting both.
Are we going to see a weird thing with memory speeds like we have in the past, where people are going to, why are you using whatever 4800 megahertz instead of 7800 or whatever?
We always do.
Oh yeah, they always say that.
And
we still get that on DDR4. So
yeah, I imagine it's going to be a similar result as well. Like it's not going to make that big of a difference, right? Maybe.
Probably. I mean, the DDR4, DDR5 difference is big, but I don't know if that's just attributable to the jump in speed or if it's also the technology differences in DDR5. Okay. I'm leaning more toward it being the technology differences, but we'll have to see. But whatever, our standard, I think, is still going to stay the same if we do what the manufacturers support. So what Intel and the motherboard manufacturers say, like, this is the spec for this CPU's memory support. That's what we're going to use. We're not going to push crazy high frequencies and stuff.
Yeah, because the RAM we used, the DDR5 RAM, it's technically 4800 megahertz, but Intel, when you're using 4 sticks, what's supported is 4400. So that's what we actually used. And that stuff is slow. It was 4400 megahertz CL40, which is awful timings. And then the DDR4 that we were using was 3200 megahertz and CL20 or CL22 or something like that. Wow. So I don't think it's just straight up RAM speed, because like in terms of like throughput, man, DDR5 might actually be worse for what we used, but we saw, I think the average was about 10% performance gain. In some cases it was higher, some cases lower, but the average was about 10%. And that's more than we saw back in the day when we moved from DDR3 to DDR4. I remember that move, and that was like, it was exactly the same for like 6 months until some faster stuff came out. So I think long-term DDR5 is going to be a bigger deal. But man, if you can't get it, you can't get it.
Yeah.
It doesn't matter how good it is if there's no supply.
Yeah. Let's see. Yeah, interesting. Don's in the chat. He says, "Hey guys, I have Linux on the system and running Intel 1 API MKL LinPack performance is the same as 11900K and Ryzen 5900, right around the 540 gigaflops range." That's curious. And he says he will check the memory performance in a minute. Cool. Well, thanks, Don. Hold on. Let's see.
I wonder if it's not accessing the E cores that well, because that would put it at 8 performance cores, which would be the same as the 11900.
Oh, yeah.
Also, Linux might have some issues with that.
It also could be, like I said, in the AVX stuff. I know for sure the E cores don't have AVX 512, which is why it's turned off as a normal feature on the whole processor. Okay. I don't know if they have like AVX2, or if they do, if the implementation is super slow, but the stuff Don's running would use any of those. So it may be that the stuff he's running is just like, I can't run on these cores or something like that. I don't know.
Interesting. Right on. Well, I guess since we're kind of 20 minutes in, let's get on it with the performance results.
Sure.
Sure.
Yeah. You want me to go first?
This one. Phew. Since you got it
Sure.
up, yeah.
I saw a couple of people were talking about After Effects, so I figured I'd
Yeah.
hit that one first because I saw someone was feeling like bad that they bought a system already or previously.
Mhm.
First of all, I mean, I do want to say, man, it's so hard because there's always something around the corner, and you never know if it's going to be a major difference or a small difference. And at a certain point, you just got to bite the bullet and get a system. Like
Yeah.
a system that could be a little bit slower is still better than a system that doesn't exist yet.
Right.
So. Yeah, I know it's always tough, but After Effects is an interesting one though because so this is all the CPUs we tested. So we pretty much tested the green ones here are the new Alder Lake stuff, and we have one result that's DDR5. Everything else is DDR4. So just take note of that. Then we tested Ryzen, the 5000 series, and then the previous 11th gen. So that's what the blue ones are, just like AMD and previous gen Intel.
Okay.
And at the top end, so if you bought a top end system, 12th gen isn't all that much faster, really. Let's see here. Let me get my numbers. So, like, versus the 5900X, so like the 12900K versus 5900X, it is faster, but it's like 6%. So, like, if you got a 5900X or 5950X, you're fine. You're not losing out that much for now. Once DDR5 comes into play, then there's going to be a small jump. I think that's about 16%. But like even 16%, like I don't know, that's not totally game changing. It's an improvement, and there are people who will upgrade just for that amount. But like overall, like that's probably you can get another gen out of your system before like your workflow is going to be significantly better. The area where Intel like really takes the lead is down at the lower end. So if you're on a tight budget, the 12600K is just like terrific. That was. Let me see here. Let me get my numbers. So that was actually the 12700K too. Both of the 12700K and the 12600K are about 13% faster than equivalent AMDs. And so that'll go up probably another, I don't know, 8% or so once there's DDR5. So it's mostly the mid lower end where 12th gen is the bigger win in After Effects. The top end, it's marginal. We'll probably end up moving our recommended systems back from AMD to Intel. Just because, it is better. And there's things like PCIe Gen 5, which we haven't even talked about. Like, that's like not important at all today, but it could be in the future. So like, some upgrading things. And like Thunderbolt is way better on Intel platforms than on AMD as well. So there's just other platform level things. So that's After Effects. Jumping from that to Premiere, because a lot of people who are using After Effects, they're also using Premiere, well, and like Photoshop and stuff too. And we'll talk about those. But Premiere is one of the coolest ones. So that's why I wanted to talk about it kind of early on here. Because man, look at this. Like here's the 12900K versus the 5900X. Like,
wow,
that's huge. It was a 30% performance difference, and with DDR5, it's actually 40%. So, and what are the other ones? The other ones are about the same. It's like 30 to 40% is how much faster Intel is than AMD now. So like,
jeez,
that's huge, like absolutely massive. I don't know if it's even a caveat to that though, is it's not across the board. So in our articles, we have another section talking about because of QuickSync. That's is where most of that performance like advantage is. But at the same time, so what you can do in Premiere is you can use QuickSync or the GPU to handle decoding or encoding really of H.264 and HEVC. Not all flavors, but like the most common ones.
Right. We have a chart for that, by the way.
Yeah, we do.
Elsewhere.
And in previous versions of Premiere Pro, it seemed like it was about the same between QuickSync and GPU. So like that's why a lot of our recommended systems are like, we'll just use AMD because the GPU will just handle it. Yeah. And AMD is better for like ProRes or Red. But it seems like in this last version of Premiere, the 22, something changed. I don't know what yet. We know the what, we don't know the why. Sure. But for whatever reason, having QuickSync makes things way faster. My guess is it's able to use both the GPU and QuickSync. Maybe it's like swapping frames. I don't know what.
Like giving you kind of an extra, almost like having an extra graphics card to help out.
Yeah, maybe. I don't know. But also too, the i9 had a big performance jump as well. So that's mostly this is from like if you're trying to do like
that's
4x
huge.
playback, because like I mean all of these ones down here, like all the Intel ones, are going to be able to handle normal playback as long as it's a flavor that's supported. Like that's
Sure.
not a problem. It's going to be like you're trying to go really fast, you're scrubbing through really quickly, and you want as fast as possible. But yeah, so it helps a lot. And I'm not quite sure why yet. The one thing I can tell you is that if you turn off quick sync, so you disable the iGPU, performance is way down here on like the AMD level, because that's now going to be using the GPU.
Crazy.
And that's actually one of my gripes about a lot of the hardware reviewers out there. So many of them disabled onboard graphics. I don't know why, and like a lot of them, they don't even say that they did. But a lot of them improperly uploaded results to our benchmark database before launch, and like we filter them all, so like no one can see them, but we can see them. And I know like very few of them had the onboard graphics enabled, which means that they were completely gimping performance in Premiere Pro. So all those benchmark results out there that are these CPUs that have like scores that are generally they'd score around here about 1,000. So if you see it like they're like, oh yeah, it's no more faster than AMD. Well, it's because they totally gimped it, and like it's not an accurate result. But yeah, so Premiere Pro, it's great. It's terrific.
Yeah. Leviathan Prime on Twitch was asking, is the 12th gen iGPU based on the Z GPU? I don't know if I'm pronouncing that right, but
I don't know. Do you guys know?
I don't think so.
It's UHD still. They still call it UHD. So I don't think I think they would call it Iris XE or whatever. Like they do that on laptops, like the ones out there that are right now that are, or is it Alchemist now? Whatever it is. They call it that on laptops, so I'm sure they would be calling it out if it was. So I don't think it is.
Yeah, I don't think so either. The official spec on Intel's ARC page is UHD graphics 770 for the 12900.
Yeah.
Okay.
Yeah, so they made improvements, but I'm sure they made improvements, and they have to have, because it's faster on the the i7, i5, and massively faster on the i9. But I need to investigate this a little bit more. Like Premiere Pro has quite wide run variations sometimes, especially for this kind of thing, where I'm not sure why. So it's possible that even though we did multiple runs, like this one is artificial and it should be up here. It's you can't artificially get high results, but you can get artificially low.
Sure.
And so it's, or not artificially, but like it freaks
accidentally,
out
perhaps.
Yeah. But yeah, it's just terrific. Like I don't see any reason for us to be using Ryzen for Premiere Pro here in the future, because even for like the other codecs, so like Red, ProRes, all that kind of stuff, it's basically that the Intel is slightly behind at the i9 level, but like its percentages, like single digit, like you're not going to notice that.
Nah.
But the 5950X still has a place. But man, most of the time when we have customers who are like, hey, I'm doing 8K Red or Blackmagic Raw, they're going up to Threadripper, Threadripper Pro, Xeon W, those kind of levels. So like that's not really the target market for these CPUs anyway.
Sure.
But man, again, like the i7 is just terrific. Like it's so much faster than the 5800X, even in these cases. The same with the i5. Like I guess that's only like 20%, but still,
only.
It's so good. It's so good.
So I imagine then, and I'm sure we can't speak to specifics, but this change is going to start applying to the X series of processors too, right? The HEDT stuff, right?
Maybe.
I would hope so.
I don't know.
Oh,
it sure seems like they've totally abandoned that market space. Like we haven't cared about it for a long time.
Yeah, I know we
don't
haven't,
know if
like
anyone has
the X299 stuff and whatever. I think
the
9 series, I think, was the last one we really carried.
Yeah.
So
we carried the 10. The 10 series was good until Ryzen 5000 launched, and then Ryzen just made it obsolete. But Intel has launched the new Xeon Ws, and there was no X series to go along with it. So it might be just a market segment that like just doesn't have a need anymore. Like even like Threadripper feels that way in some cases, where like the lower core count Threadrippers, it's like, yeah, it's marginally better than Ryzen. Like, yeah, just use Ryzen. And then once you get above that, generally you're into budget levels where someone might go up to like Threadripper Pro instead, because the extra memory bandwidth and everything else. So that whole HEDT area seems like it's kind of like getting a narrower and narrower band of products that actually make sense. So we'll see what happens.
There's some comments about like maybe the E cores are playing a role in the quick sync, and that sort of.
Yeah,
Who knows at this point? Can we talk about temperatures? Tech Notice on YouTube was asking what were the temperatures like with the NHU12. I don't think we use the U12 anymore. I think we
do. We're using the U12A.
Okay.
Mostly. In our testing, technically, we have a mix of U12S and U12A, but like honestly, we do all of our testing on open air test benches, and like it's fine. We never have throttling. That's all we really care about, is if it's throttled or not. Our product qualification is where they really worry about thermals and making sure things are cooled well. Everything I saw from reviews, though, basically put it the same as the 11th gen, which, it's higher power draw and heat than Ryzen. Yeah. But like, how many people are actually doing things where that matters as much? I guess like yes, if you're doing like CPU rendering or like code compiling, that's going to run for a long time. Yeah, maybe it's a concern, but like so many of these applications, it's about burst performance. Like there's a little bit of time for things to cool down in between, even if it looks like it's at 100%. So overall, we didn't have problems. I don't expect we'll have problems, but we also use big beefy heat sinks.
Sure. No, he had commented on it and said Linus was struggling to cool it down with an NHD15, and that's a monster guy with like 2 huge fans and stuff. So, but I've heard similar talking about, it's so hot and power draw and blah blah blah, but I don't think it's as big a deal as maybe some are making it out to be.
Yeah, I don't know. We'll see. That more is about our product qualification side. We care mostly about performance and bugs.
Yeah, performance. All right. So what's next for you, Matt?
Well, if we're just going to go through this, I guess we'll stick with video editing and talk about Resolve. So DaVinci Resolve is one where Intel again does take a lead, but it's kind of small.
That's interesting to see.
Let's see, where's my numbers? I've got an Excel chart here too to help me remember all these numbers, so I don't have to remember percentages. But at the top end, so 12900K versus 5900X, like everything up here is within like 5%, which really margin of error for these real world tests. Generally, I think like if it's 5%, you're never going to notice the difference. So pretty much everything up here, like even this 12600K is like getting close to margin of error. So it's like, somewhere in here it's fine. Yeah, so like performance isn't like super critical, which is weird. I mean, a lot of Resolve is very GPU heavy. Like the heavier the task is in Resolve, the more likely it is to be offloaded onto the GPU. So big beefy CPUs don't make as big of a difference in Resolve in some other applications because it's a lot more balanced between GPU and CPU. And for GPU stuff, so this is our GPU test results. Like everything's the same. Like, okay, yes, technically AMD or Intel ended up at the top here, but like the numbers are off by like 1.
Yeah,
so it's really
some neutrinos got in the way or something. Like,
it's all the same. It's all the same
because it's all the same GPU.
Yeah. So it's all. I think once we have DDR5, we saw a good performance bump with DDR5. That added another. I want to say, is that like 10%, 8% or something? Or sorry, here to here, something like that. So it's a small bump. I would say though that the platform level features I think makes Intel a better option than AMD, just because like things like QuickSync actually is a bigger deal in Resolve in many ways. So it doesn't look like we had that massive performance gain from QuickSync like we did in Premiere, but Resolve is a lot better about supporting all of the different codec flavors that QuickSync supports. So like Premiere only supports the basics. Resolve, if you want to do HEVC 422, you can actually use hardware decoding in Resolve. You can't do it in Premiere. So I think the QuickSync is going to make a bigger difference in Resolve for a lot of workflows. And the PCIe Gen 5 as far as future proofing, again, because since it's a lot more about GPU stuff, having PCIe Gen 5 might make a bigger difference whenever there's new NVIDIA cards. Like, generally it doesn't, but I don't know if it's balanced. If it's equal, otherwise, might as well get the one that has PCIe Gen 5.
Sure. I mean, we barely adopted PCIe 4, and now we got another one.
Well, and it rarely makes a difference at all.
Weird. Huh.
So that's all my video stuff. I mean, to keep me from talking too much, maybe we'll save the photo stuff for after Kelly goes through his. So
Sure, yeah.
Talk for 20 minutes.
Yeah, what do you got, Kelly?
All right.
We'll do a little
So
swap. Boom.
starting off with Cinebench for Cinema 40,
Classic.
the classic. CPU based renderer, not really the task that you would buy this class of CPU for,
Sure.
but still shows some good stuff anyways. Like massive jump from the 11900 down here at 15,000 points all the way up to 25,000.
Wow.
With one generation. I mean, even the 12600 is well ahead of the 11900.
That's
so
crazy.
massive.
Isn't that like a 70% gain?
Yeah. Yeah.
That's huge.
Yeah.
And then if you add DDR5 on top of that, get another couple thousand, it actually pushes it ahead of the 3950. So yeah, massive improvements here for multi-core rendering. And then single core, a pretty big bump across the board for all the CPUs too. So what this says is that like this is a great CPU for a modeler animator who's doing a lot of that stuff. Maybe doesn't do a lot of CPU rendering or small renders, or they use GPU rendering. So now they can have great modeling performance and then go out to Redshift to render everything.
Nice.
Because a lot of Cinema 40 artists are using Redshift anyways. So
all right.
But then you have some good multi-core stuff for other things too. It's kind of a best of both worlds.
Just as an aside, is like simulation things, is that more multi-threaded? Yeah, I think it's like people doing fluid simulations and
so like X Particles is like the big plugin for Cinema 40. Fluid simulations in that are multi-threaded. Other simulations are single-threaded. So it varies a lot.
But should mean that 12th gen is just better for that kind of stuff too.
Yeah.
Okay.
Unless you're doing like really crazy fluid simulations, like specifically doing fluid simulations, you might go up to Threadripper anyways. But if you're not doing that, then yeah, this is a good kind of middle ground.
Yeah, that's
and
great.
Then to V-Ray. So V-Ray is a CPU based renderer and GPU based renderer, so you can do either or both at the same time, which is kind of nice to get performance out of your entire system.
Yeah, both sounds cool.
Yeah. So this has again 11900s way down here and then 12900s all the way at the top.
Cool.
So yeah, massive improvements. DDR4 did about, I think it was like 8%, or DDR5 did about 8% above DDR4. So not massive in this case, but something.
Yeah.
Again,
I'm just shocked to see that the previous gen top end CPU is about equal to this generation's lowest end CPU. Like, well, I'm sure i3s and stuff, but I mean, wow,
it's like a $300.
That was
CPU
across
too.
the board, right?
Yeah.
Every single one of our tests. Yeah, the 12600K beat the 11900K. Every single one of our tests. Wow. Like, I don't know when that's happened ever.
Yeah. I mean, we've been talking offline about this being like, that'd be a great gaming CPU if you're trying to put together a gaming system right now.
Yeah.
You get that and then save the money to put towards your GPU that's overpriced. So, So CPU rendering is kind of interesting, right? An interesting place right now.
Yeah, that's so cool.
A lot of more options at this lower end if you don't want to spend the money of a Threadripper. Maybe you're not doing something that's that complicated that you don't need to do massive, like half-hour long per frame renders or something. So that's interesting. Unreal. This is where this class of CPU gets used a bit more.
Okay.
So code compile. This was crazy. So it dropped from, this is number of seconds to compile the source code of Unreal Engine.
Okay.
So it went from 1,677 seconds to 992 seconds.
Jeez.
That shaved 700 seconds off. So 11, 12 minutes, something like that.
Wow.
That's close to half the time.
Yeah. And that's with the DDR5. So DDR4 is 1200. This is where DDR5 made a big difference.
Interesting.
Going from 1254 to 992. Like that saves a lot, and that's assuming. I'm assuming that's just because there's so much data that's going back and forth with compiling the code. That makes that big of a difference. So that's going to be interesting to watch to see how DDR5 kind of evolves and what these other CPUs do.
Well, because this one, AMD is actually technically on top still, right? If you're doing DDR4 still.
Yeah.
This is one of the rare times we saw where even with DDR4, AMD does have a lead still.
And this just seems to be a couple things. It's just highly number of threads is like the number one thing. And then two, Visual Studio seems to just prefer AMD. Like as long as I've been testing it, whenever I test like core versus core, AMD is faster. So like the 5600 versus the 11600, that was faster. And then the 8-core 5800 was faster than either of the Intel like 11th gen. So core for core, it's always kind of favored AMD for some reason. I don't know if it's just how Visual Studio works or what. So yeah, wasn't too surprised that AMD is still on top, but it's surprising how close they got.
Yeah.
Although still at like the i5 level, that 12600K is still amazingly better than AMD.
And then build lighting. This is the one that this test is kind of slowly going away because it's just moving to GPU based. It's the GPU based render lighting in Unreal 4 and Unreal 5 is just faster on GPU and more accurate, so it looks better. But it's still, some people use it because CPU based lighting, you can actually use a swarm, so you can have all of the systems in your studio kind of work together to build the lighting, but you can't do that with GPU. So like a big game studio might still use this because everyone leaves for the day. You turn on 100 computers to bake your lighting and it's done in no time. But again, everything is so much faster. I won't go into too much detail on this one, but it's just a lot faster. Compiling shaders is a test that every Unreal person has to deal with all the time. Anytime you open a new project, anytime you get a scene from someone else or update to a new video card or something, they'll want you to recompile all the drivers. If you enable or disable ray tracing, you have to recompile all the shaders. So yeah, you'll see this a lot. And finally, having Intel actually makes sense for this because before AMD was just light years ahead of Intel for compiling shaders, but now they're kind of back in the ballgame and actually faster with DDR5 than the 32 core Ryzen or 32 thread Ryzen.
DDR5 difference on some of those tests is crazy. That's 25% less time just from having DDR5 memory.
Cool. DDR5 was a huge improvement for Unreal.
Kelly's stuff is the reason why our average gain with DDR5 was 10%.
Yeah.
If it wasn't for Kelly, the average gain would have been more like 5 or 6.
And then, okay, so people always debate FPS performance with CPUs and Unreal. And so I always include FPS results in my test, even though they're not included in the score of my test.
Okay.
And that's because of like this 4K with ray tracing turned on. Yes, Intel technically is in the lead, but by like 1 or 2 frames per second. So you'll never even notice.
Yeah.
And even going all the way down to the lowest end, 81 frames per second versus 86, you wouldn't be able to tell. So yes, you get a CPU bottleneck going, then it makes a difference, but no one's working like this. And it wouldn't make a difference anyways if you're hitting 400 frames per second versus 287. So
yeah, your eye can only see whatever frames anyway, right?
Right. And it's not going to help development workflow anyways. So whatever.
Maybe for cinematics, where you're actually recording
24
at whatever
frames,
FPS.
24 frames is cinematic enough. That's
well, but you don't play it in real time though. Like if you're going to do that, can't it actually output at whatever frame count it can do?
Yeah, it'll output at whatever it's capable of doing, either lower or higher, whatever it is. But even then, if you're getting that high, you're going to be limited to the write speed of trying to. So you create the image, but it's creating a raw image, then it has to then compress it into everything else, and then save it, write it to your disk. So you're going to be limited by that if you're going that high. But then overall scores, yeah, Intel made huge improvements. At first, we didn't test DDR5 because we didn't get that till like the day before the articles went up. So that was very last minute, and I was like, oh man, Intel really didn't do that great. It came in behind the 5900, which is like $30 cheaper or something like that. And then once we tested DDR5, that jumped all the way up to here. And so yeah, DDR5 is pretty interesting for Unreal. The 5950X is still the top, but we're getting pretty close.
Just a little bit. Yeah.
So
that's great.
I'm excited to see what the next version of this has, or if they do a X299 replacement with a lot more cores. Like there could be something, because that's all my stuff wants more cores.
It'd be really interesting. Like if they went for an HDT model, what would they do? Would they keep 8 primary cores and just add like a crap ton of efficient cores?
Well, that's kind of what's interesting about this architecture is they could do a bunch of different things. Like because if they did
way more SKUs, great.
Yeah, well, but if they did X299, it'd be a bigger die. Which is what they've done in the past. So they could do like a 16 performance and 16 energy efficient ones, or like
hopefully
whatever they want to do. They could, they can make a CPU that's like, 4 performance cores and then 32 efficiency cores if there was a use case for it that made sense. It could be some interesting stuff.
Yeah, I'm a little surprised. Well, I'm not surprised because, but like their server and workstation stuff, I'm going to be very. I mean, I guess that's kind of HEDT level, but yeah, it's going to be really interesting. Like, I mean, we already have the problem with like Xeon having like the dual socket, single socket Xeon stuff. There's way too many models, like way too many. And if they start adding in like, you can get a 4 performance and 32 core efficient, or you can get an 8 in this and then or 10 in this. Oh man, it's just going to make everything a nightmare. Hopefully they don't do that. Hopefully they find the right balance of things. But they could be really cool. Yeah, because I mean, a lot of that stuff, especially in like servers, like it's a lot of small things going on constantly. So like having a handful of performance and then just like 200 efficient cores, it could be absolutely amazing.
That'd be funny. It's like arm level stuff almost. There's hundreds of tiny little kind of fat, like kind of slow ones, but there's so many of them.
Yeah,
that'd be fun.
Yeah, because I was hearing someone was saying that these efficient cores are like the same as like Sandy Bridge, which that was a great CPU. That was what
was it, the 4000 stuff?
Yeah, I think so. Or is that 2000? Well, either way, it's like 3 or 4 gen old. But like that's not bad. Like there's still a lot of people on those CPUs. People love those things.
That's the 2000 stuff.
I remember the 2600K was like amazing. It was such a good CPU, and I really feel like this like 12900K and the 12600K is going to be like remembered at that kind of level, at least in our areas. It seems like with gaming, it's like whatever, it's just another thing. But for us, like this is like a major breakthrough.
Yeah. Let's see here. Don had some updates he was sprinkling in. On the back here, Lewis says earlier on he said just got some numbers for Linux HPCG memory bound, got 10.2 gigaflops, which is about 20% better than the 11900K, about the same as Threadripper 3900X. And then he came in just recently and said I just saw a 20% speed up on Linux HPCG memory bound with DDR5. So overall, this is not a great CPU for HPC stuff, but in general, it's pretty nice.
Yeah, I bet he meant Ryzen 3900X. Because if it's memory bound, Threadripper would have double the memory bandwidth. I don't think.
Yeah, but DDR5. I don't know. We're using kind of crappy DDR5. I mean, we're probably not going to use higher frequency DDR5 ever because again, we stick at stock. But man, the timing should get better. I hope because those are super loose timings.
Crazy.
Yeah. But the performance was already great. So like it maybe it's always weird. Like timings and stuff may just be different with a different memory technology.
Yeah, it always is.
Well, and there's also with DDR5, DDR5 has basic ECC built in. I don't think it's as robust as like full ECC, but that's a pretty darn good like value add as well. Unfortunately, it sounds like DDR5 is super expensive, so that kind of sucks.
All right. Here's a question from Tech Notice on YouTube. He says, just curious if it's possible to match the TDP power draw of the 5950X, for example, with the 12900K. What would the results be? Would Ryzen be able to match Intel, or is there more to it than more power?
That's
So
hard.
If you artificially limited, wait, are you saying artificially limit the 12900K down to the 5900 or 5950?
I think that would be the only way to get fair.
Yeah.
Because otherwise you're just overclocking the 5950X, and man, you don't get much overclocking performance these days.
Mm-mm.
Yeah.
And the TDP listed, like AMD and Intel count that differently. So you can't do
made
a direct
up numbers.
comparison. You'd have to do like power draw from the wall or something like that to
tune it.
And
and boost. Man, that'd be a really hard. You could probably get it in the same ballpark though.
Yeah.
I bet if you got it in the same ballpark, I mean, I'm totally making numbers up here. I would guess the areas where the 5900 or 5950X and 12900K are the same right now. I'd probably say maybe Intel would lose by 10%, maybe. That's my guess. Just again, totally pulling numbers out of thin air here.
Sure. Huh. There's a comment about Wendell from Level 1 Text referred to the DDR5 ECC as low level compared to server level ECC, which sure
makes sense.
Yeah, and there's a bunch of like Windows already has like error correcting built in. There's software level error correcting already. So that plus the whatever level of DDR5, honestly, like we don't see nearly as high of like memory failures these days as we used to. Memory is a lot more stable. It's still motherboard is the highest failing part, like by far. But like RAM's not bad anymore. Yeah. Unless you push it. Again, we don't push RAM because RAM is the area where you can quickly get into really unstable and like weird wonky behaviors. Mm-hmm. We have a number of customers from us who they were buying from other people before that had like overclock RAM and stuff, and we tell them to bring it down, and like all their weird problems that like that was very random, they couldn't replicate, just like occasional crashes or blue screening, those like often would clear up. So
yeah.
I think all the RAM problems that we see are caught by production during like mem test when they're first installed.
Oh yeah.
Like if it's dead from the factory, that's one thing, but after that, they're pretty much set for life.
Yeah.
Mm-hmm. So Tech Notice had an interesting question. This one's going to be straight for Matt. He says, I tested 12900K Premiere Pro live playback and above 5K, tried Red, B-RAW, Canon RAW. It was struggling, which was super surprising, yet the 5900X didn't struggle with less cores. Why might that be?
Let me double check what we got as far as Red 8K for our test, because that's we test Red H2 or 8K H265, which QuickSync is a big factor, and then we'd also do Red 8K, and we saw slightly lower performance with Intel versus AMD. It was like 10% though. Like almost same FPS numbers, almost identical. So if you're seeing something weird, I don't know. I mean, with specific codecs, there could be specific codecs. Like we don't test, Canon RAW or B-RAW right now. Well, B-RAW especially could be weird. I don't think it's actually officially supported in Premiere Pro. Like you have to do a plugin from Blackmagic, and I've heard a lot of people having problems with that. So that could be that. Other than that, like it really could just be that actual performance cores are better. Although 5900X has 12. Yeah, so it could just be more performance cores at that level could be better. I mean, honestly, I didn't care all that much about like the higher res stuff, because for us, at least, once we get into that point, like people are on Threadripper Pro, and like it's just going to be much better. So it's just one of those. I would consider that not quite the target market. You can totally do it, and if you can, but you might still have to deal with proxies and all that kind of fun things.
I had someone ask me a question on the social medias about what laptop would we recommend for 4K and better video editing. And I was like, I kind of had to pause a little bit. Like, I don't know that you should be editing 4K plus on a laptop.
You can do 4K, but above that, you start getting into it gets tougher. At that point, you're looking at more the render performance than live playback again, because you're probably going to have to be working with proxies. So the faster you can generate those proxies, the better.
Yeah.
But
we always get a lot of what the best laptop for virtual production. Like none.
Yeah, no. What?
Yeah.
Laptop? What do you mean?
might as well
I
ask
don't
what phone is
understand the people that
best for
like
virtual production.
laptops. Give me a desktop any day.
I mean, yeah, I don't know. That seems what kind of mobile virtual production are you trying to do? Like, where are you going that you would
know.
that you would need a laptop?
Yeah, if you want to do basic like development, sure, it'll work all right. Be frustrating, but it'll work.
That'd be interesting to. I don't know. It just seems interesting use case. Like, I wonder what it is they're trying to accomplish that they would need a laptop.
Love laptops
Or want a laptop.
We should sell laptops.
Yeah, oh, sure. Yeah, okay. Oh yeah, and then
Should I knock out my last couple of ones? Or
yeah.
You got a couple of comments?
No, we're good.
Just because, man, already we're somehow almost to an hour.
Yeah, that's a big deal.
So last couple of ones. Photoshop, I'm not even going to spend much time here. Basically, Intel is faster, but it's by single-digit percentages in most cases. So it's like, yeah, again, we'll probably end up switching our recommended systems to Intel. But if you've got AMD, like, it's fine. I mean, honestly, Photoshop, it's rare for someone to actually run into performance issues with Photoshop. We mostly test it because it is the most common secondary application, like out of anything in content creation. So knowing more when there's a problem is more important than knowing when something is faster. Because every once in a while we test something and like, oh, this is really bad for some reason. Like, we haven't seen that in a while, but we used to, so we still kind of test it just to make sure. So that's Photoshop. Lightroom is a really interesting one though. So so if you just look at like the second, the bottom half, like just all these blues down here, that's what we saw before. And AMD was always faster than Intel. And actually, it's mostly passive stuff. So we group our stuff into active tests. So that's like scrolling through images, doing stuff that's like actually interactive, and passive tasks like exporting, importing, that kind of thing. And active stuff, like the new 12th gen is a little bit faster, but like honestly, everything's kind of the same. It's single threaded. So like Intel and AMD from last gen are all kind of the same. But passive, again, if you just look at the bottom half and ignore this one green one, AMD was just always so much faster than Intel. So we would always use AMD for Lightroom because, like, yeah, it's just as good for active stuff, but it's way faster once you start, doing your exports and stuff, which honestly, most people care way more about active than passive, but hey, you might as well.
Sure. Hey, man, when you're importing 2,000 images or whatever, a few seconds here and there can make a big difference.
Yeah. Well, or generating smart previews. A lot of people like to use smart previews and all that kind of jazz. But Intel saw huge gains. Like for the passive stuff, I don't think I did any numbers, but yeah, we went from basically 100 to 150, 175. So that's 50 to 75% faster with DDR5. Like that's a huge gain. So whatever was hurting Intel in Lightroom has been fixed, and so now it's way better. And so that means that overall, again, Intel is on top now. They're a little bit better for active. They're better for passive. So like the 12600K pretty much matches any AMD CPU. So that's great. You get a little bit more out of the i7 and the i9, but it's not all that much. So I'm not actually sure. We're probably on our recommended systems. We'll end up using the i7 maybe. It's a little bit tough. Again, it comes down to our customer base. Our customer base tends to say, yeah, okay, an extra $100 or $200, sure. Like I'll do that to get the best. So we'll have to decide what we want to do here. But yeah, they had a nice gain. This is also, Lightroom's also a funny one because the 5950X is slower, and people always call that out as like, well, your guys' testing is wrong because there's no way the 16-core AMD is slower than 12. It's like, no, it is. It's actually even does Photoshop show this? No, some of our Photoshop testing in the past, I guess it looks like it's been fixed or whatever. But we also used to actually see the 8-core was almost always faster in lightly threaded tasks. So they at least got that better. But yeah, it's not that big of a difference. And oftentimes it's margin of error too. Like 1121 versus 1186 is like 2%. But yeah, so they fixed that. So honestly, for like pretty much everything I tested, Intel is going to be in the lead now.
Man.
It's going to be interesting, William. There we go. I forget everything's reversed. Like what we're going to end up doing with our recommended systems, because to me, like there's a straight up performance, which yes, Intel's in the lead, but also it's a new technology. There's a lot of new stuff in it. So like, is it worth doing that over an established platform like AMD? On the other hand, I know on the support side, we've tend to see a little bit higher support issues with AMD over Intel. So like, does that offset? So I think it's going to be interesting to see what we end up deciding to do.
For sure, a lot of stuff is going to be moving. It's a lot of the stuff that moved to AMD with the 5000 series is just going to go right back to Intel now.
Oh no! And then next year, AMD is going to go back. No.
I hope so.
A lot of it. Well, I mean, that's kind of the best thing for consumers, right? Is that like each generation, these companies beat the other company, and then that's what fosters innovation and competition and stuff. If one is clearly better than the other for a long time, things stagnate.
Yeah.
Cough, NVIDIA cough.
Oh, I knew. Yeah, like Intel wouldn't be doing this hybrid architecture stuff if they were on top already.
Oh yeah,
like
no way.
It's got to be so much work to do this, and a lot of work with like Microsoft and software developers.
So are we gonna hear less talk about nanometers with this sort of thing? Because like everybody was like, oh, the 14 nanometer is dead now, and like
I don't think so.
Not that really meant a whole lot anyway. I think to most, like it. Yeah, I kind of dug into it for once trying to figure out, and it doesn't actually have anything to do with the actual like size of anything. It's like one of these made up numbers like TDP. So I just honestly, maybe it won't matter as much.
Yeah, honestly, I'm at the point now where I don't care about specs. Like I don't care what the frequency is. I don't care what the core count is. I don't care what anything is, because it all like is influenced way too much by background architecture things that no one talks about, and like you can't really talk about. Sure. That at the end of the day, like I care about where it ends up on a chart,
right?
Not what any of the specs are, because it seems to be almost impossible these days to guesstimate how things will be based on specs.
Sure. So. Yeah, I mean, especially when you have, especially now, this is just threw another weird wrinkle into things with these different kinds of cores and stuff, and whether or not it's, a whole bunch of kind of slow cores or a whole bunch of or fewer fast cores, and now it's so weird. Yeah. So
I think people still debate the nanometer size because it's something easy to grab onto to debate.
Sure.
Like, oh, well, they're still using this, so therefore it's better. But like you're saying with TDP, they measure it differently. CPU cooler manufacturers measure TDP differently than CPU manufacturers do, so those don't match. And,
of course they do.
Yeah. So like it's too easy for a manufacturer to say we have X technology there's a little asterisk to what that actually means. But yeah, like Matt was saying, it's the performance. So what does it actually do?
Yeah.
The thing is, like, you can't put that onto a marketing slide. You can't put that onto a box.
Right.
So Intel, AMD, and all those guys, they're going to be chasing whatever those hype numbers are, whether it's nanometers or gigahertz or cores. Now it'll probably be threads. Now that we have like this mixed stuff, like that's what they're going to do, because that's what helps them sell their product.
Right.
Do research. Yeah. That's what I care about. How many coupled?
Yeah. Awesome. All right. Is anything you guys want to mention before we sign off here? Anything else? Should people upgrade to Windows 11?
Oh, cheapers.
Depends.
If you have less than 32 cores, I say it's totally fine too. If you have more than 32 cores, we still saw some wonky stuff that might be fixed. I guess we should mention with Windows 11 though. We did do all of our testing on Windows 11, but we also did some Windows 10 testing, and AMD saw no difference between the two. I know there's a lot of people who were concerned that hey, people are doing all their testing on Windows 11 and AMD had performance issues. We saw nothing. We saw more performance issues with Intel on Windows 11 than AMD at this point. So
cool. All right. I guess we'll wrap it up here. So thank you, gentlemen, for joining us today, taking time out of the day. It's always cool, and especially with a big major product launch like this, kind of just coming out of nowhere. I don't think anybody really expected such a jump forward in performance for this stuff. This is really, really cool. I mean, it's like what happened a couple years back with AMD and the 3000, 5000 stuff. It's really shocking. It's pretty cool. Stoked. Yeah.
Hopefully they keep to mature it and it goes better in the future.
Yeah. And as always, I like to keep
AMD fights.
which is great. Yeah, I hope I would love to see what happens coming from AMD next year or in the future soon, hopefully. So yeah, competition, yay, awesome. And I always like to thank the audience as well for joining us today. We do this every Wednesday, usually, except when funny product launch dates and embargoes and stuff happen, and then we bump it around. So thank you guys for joining. Tell your friends. We do this Wednesdays, 1 p.m. Pacific, and we bring in outside experts to talk about like their workflow, tips, tricks, and things like that. And while at the same time, we occasionally have our internal experts to talk about the crossover of those softwares and the performance of the hardware that you use. And so mark your calendars, and we'll see you all next time. Wednesdays, 1 p.m. Pacific.